So good evening, welcome to SAKALAVIDYA YouTube channel. So welcome you all once again. Any new viewers are there? Like, subscribe and share. Okay. Thank you one and all. Yesterday we have discussed up to 6 points. Okay. This is the 6th point. Last point we have discussed. So rest of the points we shall discuss and we shall switch over to the problems. Okay. Now next concept. Permutations part 2. Part 2. Next, today's 7th point. The number of permutations of n different things taken or at a time when each thing may be repeated any number of times. Is anybody? Okay, so that means actually number of permutations of n different things taken or at a time when the repetition is not allowed is NPR. NPR means n factorial by n minus r factorial. Yesterday we have discussed that one. So now you check here the number of permutations of n different things taken or at a time when each thing may be repeated. Here with repetition, this condition is may be repeated any number of times is, that we need to find out. So that means, for example, see here hint, you see the hint. Now take r blank places or empty places 1, 2, 3, 4, and so on r places. That means this is the first place, second place, third place, fourth place, so on rth place. Now the first place can be filled in any number of times, means total how many things we have, n things. The first can be filled n ways. Even we can use for the second one also. Even second can be filled n ways. This is n ways, and so on. Rth place also can be filled n ways. Now you treat the filling the first place n ways is the first work. In the similar manner, treat filling the second place is the second work. Similarly, third place third work, fourth place fourth work, and similarly rth place is actually rth work. Simultaneously in succession, r works can be done in n into n into n into r times, that is n to the power of r. So that's why here we can write required number of arrangements or permutations equals to, we can write first work n ways times second work n, fourth n dash. How many times we can write r times? If n multiplied by r times, we get n to the power of r. This is the formula. See, now we can write this is n raised to r. The formulation, very simple formula. This is called with repetition. This actually we can consider this one as like this. So here with red ink I will write with repetition. Repetition is allowed with repetition. Condition. I hope everybody will understand. Right. So now let me move to the next concept. Right. Let us move to the next concept now. Eighth concept. Number of permutations of n different things taken or at a time when a particular thing is to be included in each arrangement or permutation. Each arrangement is. So unless it is mentioned, you must remember one thing. Unless it is mentioned, we need to consider as without repetition. Not repetition means if it is mentioned repetition, you need to do the repetition. It is not repetition. It is without repetition. You remember now. Number of permutations of n different things taken or at a time when a particular thing is to be included in each arrangement. So out of n different objects, one object need to be included in each arrangement. that one object should be arranged in each of the arrangement. It should present. That we need to write it now. So now you see the number of permutations of n different things taken are at a time when a particular thing is to be included in each arrangement is. Okay, so this is actually considered without repetition itself only. Now see the hint. Let me explain the hint. Now you take here let us take r blank places 1, 2, 3, 4 and so on. This is rth blank place 1, 2, 3, 4 and rth blank places is to be filled with n different objects. Particular thing is included. So for example, particular thing can be placed. See, first point you remember like this. So first task means the particular thing. The particular thing can be placed actually here. This is either first place or second place or third place or fourth place or rth place. It may be filled. That means particular thing can be placed in r ways. How many number of ways? R ways, because we have r empty places, r blank places. Now having filled any one of the faces, for example, let us fill this is with a1 particular object. It is filled, already filled. Now how many places are there here? We have remaining places are r minus 1 remaining places. How many things we are left? N minus 1. That means that can be done. Second, remaining n minus 1 things can be arranged in r minus 1 places. So therefore this is the first task. You treat this one as a first task. This is the first task or first work. This is the second work. So now we need to write a required number of ways or arrangements is equal to, this is r, first r multiplied by the r minus 1 places can be filled with n minus 1, means you can write n minus 1 p r minus 1. This is the formula. Not n minus 1 p r minus 1. It should be multiplied by r. You must remember. Suma. See, this is, we can write now this one as r multiplied by r ways, and now one element is already filled, n minus 1, already one place is filled. Now r minus 1 places, n minus 1 r minus 1. This you remember, this one. Understood now all of you? So very easy. Actually the permutations and combination chapter is very easy chapter. If you understand this chapter, probability in an easy manner you can do it. So this is actually easily we can solve the problems of even probability also. Right. Next, let us go for ninth concept. Ninth concept. I will discuss very clearly, don't worry. So after that, because the problems easily we can complete if you understand the concepts. Number of permutations of n different things of n different things taken or at a time when yes particular things are to be always included in each arrangement is. Now what is your answer? See, I repeat the question. The number of permutations of n different things taken or at a time when s particular thing, not a single particular thing, s out of n s particular things are to be included, always included in each arrangement is. Simply you apply the concept. So fill in the blank places concept we need to use. So now let us divide into the two works or two tasks. First place, second place, third place, fourth place, and so on. This is the rth place. So now you take it, this is the first place, second place, third place, fourth place, and this is the rth place. Now yes particular things always included. So first you arrange the first task, start with the first task. See, this s particular thing should come in each arrangement. That means r places can be filled with s ways. Now r places to be filled with yes things. So that is, actually we can write that is RPS ways. Okay, this is the first task completed. Now having been filled R things, So now how many remaining things are there here now? N minus R things. Now this N minus R things to be filled in how many places? Already S places are being filled. Now the places are R minus S places. That is, we can done N minus P R minus S. Therefore, you see required number of ways is equal to required number of arrangements is equal to first work can be done RPS ways multiplied by second is N minus R P R minus S. So this we need to write it now. This is RPS multiplied by N minus R P R minus S. The previous case only one thing, now many things can be. So this we can remember. Just go through this concept now, all of you once again. Right. So now, okay. Kalyani, after a long time. Tenth one. Number of permutations. Number of permutations. Uma. Number of permutations of n different things. N different things taken or at a time when a particular thing is always not included in each arrangement is. Thank you Kalyani, thank you. Okay, how are you Ashok? Fine. See, the number of permutations of n different things taken or at a time when a particular thing always not included in each arrangement. That means a particular thing should not be arranged in the each arrangement. That means we need to keep the particular arrangement aside. If you keep the particular thing aside, that means there will be actually out of n one thing is kept aside. So total there will be n minus 1 only. Now places are r places. That means now we need to fill r places with n minus 1 things without repetition. So that can be done n minus 1 PR. That's all. N minus 1 PR. So that means let us do like this now. Here are empty places or blank places. 1, 2, 3, 4, and next this is rth place. First place, second place, third place, fourth place, and rth place. Understood now? So now what is the condition? A particular object or thing, is kept aside. Now we are not considering it for the arrangement. So that is remaining objects or things. Remaining things are total how many? N. That means n minus 1. Now these n minus 1 we need to arrange in r blank places. So this can be done n minus 1 ways. N minus 1 is, this is n minus 2, n minus 3, and so on dash dash dash. We know that required number of ways is equal to required number of arrangements is equal to r blank places are filled with n minus 1 things without repetition. That can be done n minus 1 PR. So please my dear children, remember this is n minus 1 PR. I hope you understand this one. Included, may not be included. Included and may not be included. All of you understood? I hope it is very clear. I think so. If it is clear, that our chapter becomes very easy and you can do any problem in permutations and combinations. Generally, I know actually as far as my experience is concerned, so most of the students actually will feel this chapter very difficult, but it is not difficult, very easy chapter. Okay, because in the other chapters we have so many formulae, but with the help of the concept this problem can be solved. Okay, next, and moreover one more important point you remember, already yesterday we have discussed, but once again I repeat, this NPR also can be written as like this. One object is not included, that is n minus 1 PR. A part plus a particular object is included, R and n minus 1 PR minus 1. You can write this one also, NPR equals to. So yesterday we have discussed. So not at all any confusion, So please be cool and go through the once again video. Once again check the video. Definitely your all queries can be clarified. Shankar Narayana. Now next 11th one. Number of permutations of n different things taken all at a time. Taken all at a time means n. Taken all at a time. When m specified things always come together is. So anybody give the answer? The number of permutations of n different things taken all at a time. Taken all at a time. When out of n, m things, specified things should always come together. Is. For example, one question may be there. So the number of arrangements of the letters of the word, some equation taken all at a time, such that all the vowels come together, all the consonants come together. Such type of questions can be solved with the help of this concept. If you go through this concept, such problems easily we can crack in a simple manner. Understood now? In general, actually we do not need paper, pen for these problems if you know the concepts. So let me do the concept, don't worry. So for this problem, the method is known as string method. String method we can follow. So what is the string method? Let me explain, but don't write it string method as like that. But let me explain the concept of this one. Video is not clear. Okay, wait. I will check the video. Wait. I will check the video. I will check the video. So 1 minute. It will be clear. Don't worry. Okay. Kotta Ritika n factorial and m plus 1 factorial. Right. Now it's clear. It's clear. Ashok, clear? Are you there, Ashok? Balu? Thank you, Divya. Okay, let me explain. First, that means what we need to do means here the number of permutations of n different things taken all at a time, this is important, taken all at a time when m specified things always come together. That means these m things we need to make a one unit. First see, let us consider m things as a pack, m things as one unit. This is very important, one unit. Okay, so having been actually considered the m things as one unit, now how many things are there? Now we are left with n minus m plus this one unit also you need to consider as, it's very important, one unit also should be considered as one object or one thing, one object. That one object need to be added here, n minus 1 plus 1 things we are left with. This we need to arrange. So now this can be arranged in n minus m plus 1 factorial ways. But among m things, they can be arranged in m factorial ways. This is the first task, this is the second task. Therefore required number of ways is equal to, you remember, that is, first is m factorial into n minus m plus 1 factorial. This is very, very important. Understood now? So I will explain now. Now it's okay. Okay, I will explain. So m specified things always come together means you make m things as one unit. Now subtract from m things from total things, add this one unit. One unit is one object now. N minus m plus 1 factorial, that can be done. But among m things are because different things there. They can be arranged among themselves m factorial ways. So now you need to treat this one as the multiplication principle. First work can be done n minus m plus 1 factorial ways. Second work is n factorial. Both the works in succession can be done. That is n factorial into n minus m plus 1 factorial. I hope all of you understood. If you understood, you chart yes, yes, yes. Otherwise, no, 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 no. See, I will check how many yes and how many no's. I will check how many no's and how many yes. Thank you, Ashok. Clear, Ashok. Suma. Okay. Okay. Oh, very good, very good, very good, very good. Wonderful, wonderful. No. Ready. Okay, one member. Right. Thank you. Now, I ask you one question. Now, all of you stop now. I ask you one question now. The number of permutations of n different things all at a time when m specified things should not come together. How shall you do this problem? Just you think of like that also. They should not come together. That means m specified things never come together. They should be away. Because for example, sometimes girls and boys are there. Girls and boys need to be arranged separately. Girls should not come together and boys should not come together. So we need to arrange. In such cases, what shall we do? So let us think for a while. Okay, let us come to that case now. Here, understood now? This is, now let us write here, is m factorial to n minus m plus 1 factorial. This is the formula. Right. npm, Suma. Okay, npm. Next, we talk about the 12th concept. 12th concept. What is the 12th concept now? Number of permutations. Number of permutations of n different things, n different things taken all at a time, when m specified things, m particular things, specified things never come together. In the previous case, always come together. Now never come together is. So this is anybody. So what you need to do now, that means first total number of permutations we need to find out without any restriction. Next, the number of permutations with restrictions find out. The total number of permutations minus next the number of permutations with restriction. With restriction means m specified things come together. First come together, find out. So this can be done in like this now. First step, you remember, you need to find out like this. First step, number of permutations of n different things taken all at a time equals to, this is very simple, I take green color, NPR, without any repetition. With repetition means n to the power of r. Please remember, this is NPR. Okay, very good, Amma. Very good. Second case, now you need to consider. Now I take another color, red color. Number of permutations or arrangements. Number of permutations of n different things in which m specified things come together, come together. This is equal to, take another color, green color here, already done, that is m factorial, one pack. We need to subtract m things from n, that is n minus m, add that pack and factorial. Now what we need to find out now? Therefore, your required number of ways is equal to the required number of permutations equal to 1 minus 2. So that equal to NPR, sorry, not NPR, this is NPN, sorry, absolutely, NPN, all taken at a time, n factorial, that is. So that means you can write this is n factorial instead of 1. This is n factorial minus m factorial times n minus m plus 1 factorial. So understood now. So the number of permutations of here n different things taken all at a time when m specified things never come together is n factorial minus m factorial into n minus m plus 1 factorial. This you need to remember like this: total minus restriction with restriction. Total minus number of permutations with restriction. Understood now? Third one. 13th one. This is very important. Very important. This concept is very important. Please remember. Number of permutations of n dissimilar or different or both are same, no problem, any word you can use. N different things taken or at a time when at least one thing is repeated. At least one thing is repeated, not all. At least one thing is repeated. At least one thing is repeated. At least one thing is repeated means actually out of r things. So one thing, two things, three things and r things, that we need to find out. So that means actually here what we need to find out now, the number of permutations of n different things taken or at a time with repetition, we need to find out. Next, second case, what we need to find out means number of permutations of n different things taken or at a time without repetition. From with repetition minus without repetition, you get it now. At least one thing is repeated, that you will get it. So very good. Prasanna Hani, Vaishnavi Vinayaki is correct. Okay, now let us do like this. First case, number of permutations with repetition. Simply write on that, sir. With repetition. Repetition is allowed. equal to r blank places filled with n places with repetition. N into r times, that is n to the power of r. Second, see, number of permutations without repetition. Number of permutations without repetition. Without repetition. Without repetition, we have the formula, NPR formula. Therefore, number of permutations at least one thing is repeated. One thing is repeated is equal to with repetition minus without repetition, n to the power of r minus npr. So that's, you remember, n raised to r minus npr. This is n to the power of r. N to the power of r minus npr. Very good, very good, very good. Very good. What about Suma? Where are you? Swati Singh. Balu. Okay. N to the power of r minus npr. Understood, all of you? Yes or no? Okay. Right. Next now, circular permutations. Circular permutations. Circular permutations. That means if the objects or things arranged in a circular manner on a circle, so that arrangement is called circular permutations. Circular permutations. So in that circular permutations, actually, let us go for the concept number is 12, 13, okay, 14th concept. 14th concept. 14th concept. Let us write the 14th concept. Okay. Number of circular permutations. Number of circular permutations of n different things. Of n different things. N different things is, that means taken all at a time, that we need to remember. For example, take a circle like this. So first what we need to do means ninth concept. Okay, ninth concept is very simple concept, Suma. See, first actually with repetition minus without repetition is gives us at least one thing is repeated, one time is repeated. Yes, Garland type. Oh, very good, very good, very good. Okay, okay. So now see, whenever we need to arrange n things means first fill one place with actually how many places here we have? 1, 2, 3 and so on. We have here n places. First place fill with one object. Now remaining we treat n minus 1 places as linear only. The n minus 1 places can be filled how many ways means n minus 1 factorial ways. So this is actually, we can say, this is anti-clockwise This is anti-clockwise direction. So whereas this direction is called clockwise direction. This is clock, this is anti-clock. Anti-clock. There will be, this difference will be there in this one, clockwise direction and anti-clockwise direction. That also I will give the formula directly. So 15th one. Number of circular permutations of n different things when clockwise and anti-clockwise clockwise and anti-clockwise arrangements are not different is, you need to remember, of multiplied by n minus 1 factorial. So this is particularly, remember one thing, whenever in the case of beads, example, arrangement of beads in a garland, flowers, so you make use of this formula. Generally persons, you need to consider this formula, that's all. Whenever in the question, so Suma, in the ninth concept, actually with repetition means n to the power of r. In the with repetition means, in that without repetition will be there, with repetition will be there. At least one means with repetition minus without repetition. That's why I have written n to the power of r minus npr. In the case of beads and flowers arrangement, you need to take the formula clockwise and anti-clockwise arrangements are not different. They seem to be same in the flowers. While arranging the garlands, any beads in a necklace problems. So half into n minus 1 factorial we need to consider. For any persons or any objects other than flowers and beads, they seem to be different, then n minus 1 factorial we need to consider. So okay. So next one now. This is shortcuts, important shortcuts. So now important shortcuts. Okay, particular things, that one. Okay, I will explain. Okay, don't worry. You make a call now. After completion of this session. Right. The first shortcut, remember, all of you first shortcut. Yes, linear permutations means whenever one work need to be considered along with the circle, first circular permutation, after that followed by the linear permutations only. The sum of digits, this is very important. Sum of digits in unit places, of all numbers formed with help of with help of A1, comma A2, comma A3 and so on dash dash an digits. They are digits. Digits at a time is given by. So now we need to form the shortcut for this one. So for example, you are asked to find out the sum of the digits in the unit places of all the possible numbers are formed with the help of the digits a1, a2, a3 and so on an. So here digits are, we have a1 digit, a2 digit and a3 digit and so on. Actually that is an digits. So that is given by, actually you remember, that is given by, so n minus 1 factorial times a1 plus a2 plus a3 plus and so on dash dash an. So for example, you consider one example here, consider here. The sum of digits in unit places of all numbers formed with help of 2 3 4 5 taken at a time is, for example, this question is given. The sum of the digits in the unit places of all numbers formed with the help of 2 3 4 5 taken at a time. Taken at a time means actually the 4-digit numbers will be formed. From 2 3 4 5 we get 4, actually different 4-digit numbers can be formed. How many 4-digit numbers can be formed means, that is 4 factorial, 24. In 24 we need to find out sum of all the digits which are in the unit places, that we need to find out. So that means very simple, actually here we have how many, very good Suma. So here we have actually 4 digits, understood now. Otherwise you need to write 24 digits. Out of 24 digits you need to see the check the all the unit digits, and you need to find out the their respective sum. So instead of doing like that, very simple manner we can do here. Now this can be done like this. See the solution. Here number of significant digits also we can say, because 0 is not there. That's why you can take n is equal to 4. A1 is 2, A2 is 3, A3 is 4, A4 is 5. So using this formula, sum of the digits in unit place, without calculating, that is n minus 1 factorial, 3 factorial multiplied by 2 plus 3 plus 4 plus 5. 3 factorial means 6. This is 14. 14 6 ja 84. The sum of the digits in unit place is Jai PUBG. Okay, now is going to be China. Wait. Right now. Thank you. Okay. Right, I did it. So this I will explain the concept also. What is the concept for this one? Very simple way we can concept. So for example, you take 4-digit number here. 4-digit number. So 1, 2, 3, 4 places. So 4 places means this last place, unit place means this is the unit place, 1th place, this is the 10th place, this 100th place, this is 1000th place. Am I correct now? Fill the unit place. How many number of ways you can fill? This place can be filled. This place can be filled with either 2 or 3 or 4 or 5. Because if you filled with 2, rest of the numbers filled with 3 ways. That can be filled actually. The numbers which are consisting of 2 is actually 3 factorial ways. The numbers which are consisting 3, that is also 3 factorial numbers. The numbers which are consisting 4 in the unit digit, that is also 3 factorial. The number which is consisting of 5 in the unit place, that is also 3 factorial. Understood now? But in each number, the value of 2 is 2 in the unit place. How many such numbers are there? 3 factorial. So that means the contribution of the 2 in the unit place in all numbers is 3 factorial into 2 plus the contribution of 3 in all numbers in the unit place is 3 factorial into 3. The contribution of 4 is 3 factorial into 4. The contribution of 5, 3 factorial into 5. That's all. So I have take 3 factorial common. If you take 3 factorial common, you get 2 plus 3 plus 4 plus 5. This is the rationale or logic behind this question. Understood all of you? Everybody? This NF is for JEE. Definitely for JEE also, if you know the concept, any problem you can solve. JEE, whatever competitive entrance examination, not only JEE, for any competitive entrance examination, this is very, very important. I hope everybody will understand this concept, this content. Thank you. If you just actually like my content, so like, subscribe and share to your friends. See you. Bye bye. Thank you one and all.